Welcome friends on my YouTube channel. I am Pooja Rikhi. My previous video was on introduction and representation of sets. You can see link of that video in description box. Today we will discuss types of sets. In types of sets we will discuss empty set, singleton set, finite set, infinite set, equal sets, equivalent sets, subset, proper subset, superset, power set, universal set, disjoint sets and overlapping sets. First one is empty set. A set is said to be an empty set if it does not contain any element. In other words, we can say a set with no elements is called empty set. It is also called null set or void set. It is denoted as this. Here you can see that is a symbol of phi. Phi is also used to represent an empty set. Now consider example to understand empty set. Here A equals to curly braces start x colon x is natural number less than 1 bracket close. It means that here x consider those elements in it which are less than 1 and which are natural numbers also. But we all know natural numbers starts from 1 only. So there will not be any element which exists in set A. So it is an empty set. Here is a note, set 0 is not an empty set. Now singleton set. A set containing a single element is called a singleton set. Or in other words we can say a set with one element is called singleton set. Here example of singleton set is set 2 is a singleton set and set 0 is also singleton set because it contains one element in it. Now finite set. A set which is empty or consists of a finite number of elements is called a finite set. For example, here set A represents the set of vowels. Here we can easily count the number of elements in A. Here are 5 elements in set A. So we can say A is a finite set. Now here set X represents the set of natural numbers less than 7. So here we also count elements of X. So it is called finite set. Now infinite set. A set that has infinite number of elements is called infinite set. For example, here set n represents set of natural numbers which starts from 1 and goes up to infinity. Another example of infinite set is set of all prime numbers. Here is a note, all infinite sets cannot be expressed in roster form. Now equal sets. Two sets A and B are said to be equal if they have exactly the same elements. In other words, we can say equal sets have same elements. We can represent equal sets like this, A equals to B. Here are examples of equal sets. First one is here set A represents set of natural numbers less than 5 and set B also represents set of natural numbers which are less than 5. Here the elements of A are represented by set builder form and in set B the elements of B are represented by roster form. The elements of A and B are represented in different ways, but both sets A and B have same elements, so they are called equal sets. Here is another example. Set X and set Y. Both sets have same elements, just the order of elements is different in both of them, but they have exactly same elements. So we can say X and Y are equal sets. Here is another example. Here set P has elements 1, 2 and 3 and set Q has elements 3, 2 and 1. Just the order of elements is different in both of them, but they have exactly same elements, so they are called equal sets. Now equivalent sets. Two finite sets A and B are said to be equivalent if they have same number of elements. Equivalent sets can be represented by this. Here are examples. First one is set X has elements 1, 2 and 3 and set Y has elements A, B and C. Here you can see X has 3 elements in it and set Y also has 3 elements in it. It means both sets X and Y have 3 elements in them, so the number of elements are same in both of sets, so they are called equivalent sets. Now another example. Set P equals to 0, 1 and here set P has elements 0, 2 and 4. It means P has 3 elements in it. And here is set Q, which is equals to X, such that X is a letter of word door, bracket close. Now set P has 3 elements in it. Set Q also has 3 elements in it, that is D, O and R. By the definition of sets, we will not repeat any element in set, so we will consider O one time in set Q. So at the end we can say P and Q both have 3 elements in them, so they are called equivalent sets. Here is a note: equal sets are always equivalent. Subset. If every element of a set A is also an element of set B, then A is called subset of B. In other words, we can say elements of A are also elements of set B. Then we will say A is a subset of B, and we can represent subset by this sign. Here we will read it as A is a subset of B. Now example. X has elements A, B and C in it and set Y has elements A, B, C, D and E. Here elements of set X are also elements of set Y. So we can say X is a subset of Y. Now proper subset. A is said to be proper subset of B if A is subset of B but B contains at least one element which does not belongs to A. And we will read it as A is a proper subset of B. Here that is a symbol for proper subset. Here is example. Set A has elements 1, 3, 5, 7 and 9 in it and set B has elements 1, 3, 5, 7, 9 and 11. Here all the elements of set A are in set B. It means A is subset of B. But 11 is element of set B only. It means set B has one element more than set A. Now A is subset of B, but A is not equal to B. So we can say A is proper subset of B. Superset. If A is subset of B, then B is called superset of A. Example. Here A has elements A, E, I, O, U in it, and B has set of all alphabets of English language. Here all elements of A are in set B. So we can say A is subset of B and B is called superset of A. Power set. A collection of all subsets of a set A is called power set of A. Here we can represent or denote power set like this. Power set. In power set, every element is a set. Let us consider example. Here set A has elements P and Q. Then the power set of A will be like this, which has elements phi, set P, set Q and set P and Q. Universal set. Universal set is the set which is the base for every other set formed. Universal set may be finite or infinite set. All the other sets are called subsets of universal set. Universal set is represented or denoted by capital U. Here is example. Here set A has elements 1, 2, 3 and set B has elements 2, 3, 4 and set 3 has elements 3, 5 and 7. Then universal set will be like this, which contains all elements of A, B and C. Here A, B, C all are subsets of universal set U. Disjoint sets. Two sets A and B are said to be disjoint if they do not have any element in common. For example, here set A has odd number of elements in it and set B has even number elements in it. So here we can see set A and B do not have any element in common. So we can say set A and B are called disjoint sets. Overlapping sets. Two sets A and B are said to be overlapping if they contain at least one element in common. For example, here set A has elements A, E, I, O, U and set B has elements A, B, C and D. Here you can see element A is common in both sets. So we can say A and B are overlapping sets. Thanks for watching the video. Please do like, share and subscribe my channel. Thank you so much.